Okay, today's session I will start off with one more class which supports a key value pair that is called as Hashtable. Okay, so notice T is small there. Okay, so always remember when you are using Hashtable, this class, see to that T is in small case. Hashtable. Okay, so this also supports what? Key value pair, same. And next thing is it is legacy and re-engineered. Okay, legacy and re-engineered. Okay, means see, whatever you in this hierarchy what you are saying, this support what we got is you got it from 1.2 version of Java. Which on these classes, linked hash map, tree map and all, we got it from 1.2 version. So it's not that key value pair was not there in 1.0 and 1.1, it was there. Okay, and these two classes were supporting key value pair in 1.0 version. So in the first version when they released 1.0, okay, these were the two classes. See, in 1.0 actually there were 5 classes which were released: vector, stack. Do not forget that. Okay, then you got dictionary, then you got hash table, then you got properties. So these are the 5 classes which were released to work with values in primary memory. These two were supporting collections. These 3 were supporting key value pair. Okay, these 2 were supporting collections, and they are supporting which data structure? This was supporting array data structure. This was supporting stack structure. This was the earlier support what we are having. Done. So then dictionary was supporting, all these were supporting what? Key value pairs. So this was only support what we got from the first release of Java. Okay, from the first release. Okay, but see here the problems with this legacy we have already discussed. They were, one is the big problem was they were synchronized. Means in multi-threaded environment they are having very bad performance in multi-threaded environments. Okay, so then next is one more problem with this legacy is they supported few data structures. Very few data structures. So this was the scenario in 1.0. That is when what they did when they released in the 1.2 version, when the version was released, they added too many classes into their library. So it is with experience. Java goes on building libraries. Obviously all things have been built with experience only, and Java has got tremendous experience in all that, and they released this. Okay, so this was the initial thing what happened. And here what happened, if you see the hierarchy here, coming to see these two live. Your object, okay, was the superclass, vector was the if you see the hierarchy of this, yes, vector was a subclass of object, and later a stack was the subclass of vector. But now today it is re-engineered to implement what? List. Understood? Means vector and stack will support what? Both old methods plus new methods. Same way here also, coming to this hierarchy, hash table, properties is a subclass of hash table. Hash table is a subclass of dictionary. Dictionary, for your information, is an abstract class. Dictionary, for your information, is an abstract class. Okay, so this is the hierarchy between these 3. So what happened was so today what has happened, you can notice here, hash table is extending dictionary. It still continues. Means hash table gives the support for what? Old methods also. Plus it gives the support for new methods also. So in hash map, linked hash map, tree map, you will not find the support for old methods. You will find only new methods. But here you can find the support for old methods plus new methods. That is what you mean by re-engineering. It was reconstructed to support legacy methods also plus new methods also. They implemented it. That's it. Done now? So this is the story. Okay. So then more things to understand. So here if you see the hierarchy, how it will be now? Actually hash table is still extending what? Dictionary. This one thing. But many diagrams you will not find it. But this is the actual case now. Understood? So these 2 classes will support methods present in map interface plus these 2 plus the methods of dictionary class also. It will support both the methods. And for your information, this is an abstract class and this is an interface. So it is extending this and implementing that. Fine. So that's about the hierarchy introduction. Anyway, end of the day, you have to understand what functionality it has. That's it. Understood? So if you know hash map, you know everything about hash table. There's nothing bigger. Okay. Hash map and hash table, there's no difference at all. There's no difference. Okay. There are only, maximum things they are same, but there are two major differences. I'm not saying no difference means there are slight differences. Almost all functionality wise, the methods almost all same. Okay. The two major differences are, see, this is legacy now. So the only problem with this hash table, now we are discussing hash table today, is problems with hash table. It is same as hash map, which we discussed. It is same as hash map, which we discussed in the last session. Okay, but there are few differences which are there. First is, it is synchronized. Second one is, it does not support null keys and null value. This is the major problem. So in the old classes which you have, okay, with these two, which are hash table and properties, you are unable to store null key and null value. And obviously you might get a null key, no? Supposedly from the database you are picking a value. Okay, like say a phone number. A phone number you have not made as a primary key. So obviously you can expect what? Null value. In unique constraints, null is allowed. So I want to store a phone number as key and name as value. So when you get a null value, what will you do now? Understood? See, this is a table now in your database. So this is employee ID. This is employee ID. This is name. This is phone. And this is email. Let's look at the possible conditions now, permutation and combinations. One not one, Ravi, phone number 111, Ravi @gmail or something. 102, Kumar 222, Kumar @ something you can take, cluster.com or something. So now there is an employee, possible chance that Ravi Kumar, Vinay, he doesn't have a phone. Possible now. There's another employee. Just see the scenarios you might get. In fact, you should design your table properly where null values only are not there. But by chance, somewhere null value is there. Okay, and you want to retrieve these values and store it into primary memory now. See the problems. There's one more name, Balaji. So he doesn't have what? He's having phone, but he doesn't have email. Now look at the permutation and combinations. I want to make phone number as the key, name as the value. So you might get a null key now. But the legacy classes are not supporting what? Null keys. Not only that, supposedly, see, null key means your key will be like this now. Hash table ht is equal to new right hash table ht is equal to new hash table ht dot put. So I'll take phone as the key, name as the value. Now name coming, which one is coming now? Phone number is null now. Okay, look at the other way around. This is null key. So here, this is an example for what? Null key is not allowed. What did I put? ht dot put phone comma name. Now null value is also not allowed. Null value is also not allowed. ht dot put, example for that. Supposing I'll take ID and email. Example. ID comma email. Now email is the value now. It will not allow you. So this problem was there in legacy classes or old classes. They are not supporting. Not only that, even properties class also was not supporting null key and null value. So these were the two major drawbacks of hash table. So they didn't remove that class because this class was used by many people already in their code. So only what they did is they released a new class called as HashMap, which overcomes the problem of these two. So still you have the option of using what? Hashtable also, HashMap also. But only when you are using Hashtable you should be a bit careful that it is synchronized and it is not good in multi-threaded environment. One thing you have to understand. And next thing is, it does not allow null key and null value. If you are comfortable with these two, you can still use this Hashtable. And this class is used extensively in many places. So do not neglect this, because there are so many old codes, 1.0, 1.1 version, which are using what? Hashtable. Understood? So whatever you learnt about HashMap is true for Hashtable now. Only thing is, it is not allowing null key, null value, and it is synchronized. That's it. So almost all the same programs we are going to see now. Whatever you saw in the last session, same programs. Understood? Shall I clear all this now? So I have to be very practical, okay, and think, okay, about all this. Yes, we'll see some, you got this hierarchy now? Any questions here in the hierarchy? So we are going to study now, hash table. Okay, T is small, remember. Okay, once you complete hash table, again properties will be very simple now. Only same concept with some extra new methods, that's it. So if you want, you can see some notes on hash table. Hash table, linked hash map, yes, we are going with this. Now these are the different things what you have to understand here. Go through this. Hash table can store what? Key value pair. Understood? It uses hash table data structure to store the keys. Same. Hash table class is using what? Hash table data structure to store the keys. That is why it is getting the name. It has got the name of what? Hash table. Why? Because it was using hash table data structure to store the keys. Understood? So are you clear with the second point? It uses hash table data structure to store the keys. Then next, hash table is a legacy, and it was extending dictionary class. Whatever I told you, I am just putting into document now. Then next, hash table is re-engineered to fit into collection framework and is implementing map interface. Hence it supports both 1.0 and 1.2 methods, both. Next point, the fifth point, hash table is same as hash map, but hash table is synchronized and hash map is not synchronized. Done. Now hash table is synchronized, means multiple threads cannot access the hash table object concurrently when you're working in multi-threaded environment. Okay, so that is web applications and all that. Okay, so there it will not have good performance. Okay, because only one thread can access the object at a specific time. Next, since hash table is synchronized, it has low performance than hash map. Understood? So before to Java 1.2, there was an interface called enumeration to visit the elements of hash table, but now we have iteratory interface to visit the elements of hash table. Same. So for iteration you can use enumeration or you can use iterator also. For which class? Hash table class. Yes. The keys will be unordered, you know that. Then duplicate values are allowed. Different type of keys and values, different type of keys and values are allowed. But last thing is the 12th point, very important point, null keys and null values are not allowed. This is about hash table. So this is the concept. Now I have to give you some examples and justify this. So do not learn your programs in by-hearted way. I will give you plenty of programs. In every program there is terrific concept. So focus on the concepts in the program rather than seeing the output. So let's go into this subject now. So hash table is the 12th project what we will be referring to. Hash table. Okay, all the examples have been kept in a single package here. We'll start off with the first example. Yeah, only 3 examples are there. Okay, so we'll see this. Yes, first we'll study about adding key value. Okay. See here, hash table. Put. Okay, you are clear with this now? It will be using the hash code. When hash table will be created, it will take the hash code and it will put the key into the table. Now I'll draw it and show it for you if you want. Okay, then next, first see the output. hash table dot put. I am putting what? Different type of key. And okay, different type of key. Here what I am putting? Different type of value. So different type of key is allowed, different type of value is allowed. And next, duplicate value is allowed. Then next, and this is what you have to understand, these 2 points now. You cannot put null key also, you cannot put null values. Yes. But don't see here, see it from practical in applications. You might be getting values dynamically which is null. Here you might think, oh, I know it is null, why should I put null? Okay, but in an application we can't predict where the value will be coming from. So you think like that. So if you are expecting a null value, do not use this particular class only. Understood? Means you can prefer to use which one? Hash map use. That's it. Yes, see here. It is unordered. Is it storing the same order as inserted? I put first which one? Kumar, Ravi, Amok, but look at the order here. Done? Okay. Now what happens if I put a null key? Just I'll remove this comment. Null pointer exception. So null key is not allowed. Means this is an interview question only. In a collection, when you get null pointer exception. So when we add some value into a collection which does not support null values, we get null pointer exception. Very good interview question it is. Understood? Fine. See, now I am putting null value. Understood? In tree set also, if you put, what happens? You will get null pointer. So any collection class which is not supporting null will get this exception. Are you clear with this? So if you want me to draw, yes, it's very simple. The same diagram of yesterday we can use it here. Not at all a problem. Yes, so when I say hash table, HT is equal to new hash table. Yes, let's look at the constructor now. First, document. So document, don't refer. Output you'll understand, man, but it's always better to refer to. This is only once what you'll study. Throughout your life, you're not going to study like this because you'll get the grip onto the subject. Whenever you want, you can go on using it now. So you can go to the docs. Yeah, so there are how many constructors? 4 constructors. You know the rule. I mean, you know that all these constructors: capacity, load factor, map. Okay, but this one little bit you have to focus. Constructs a new empty hash table, but the capacity is 11. Unlike other things which are having 16. That's only difference. Load factor is same. How much? 0.75 only. But it is having capacity of 11 this time. Done? So that's why always refer and work. It will be helpful for you. Fine. So now when I create a hash table, now how many elements will be there now? Buckets. Capacity will be what? 11. And fill-in ratio or load factor will be 0.75. So enter now. This is when I say this is the hash table which gets created. Now be careful. So I am putting space here. When I create an object of hash table, one hash table gets created. Understood now? So what will this hash table have now? I need space. This is the key. This will be the hash code. So which object is this? Hash table object, HT. So total it will have how many buckets? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sit and count approximately like that. Okay, now once this object has got created, capacity is 11 now, not 16. And load factor is 0.75. Means as soon as 75%, that is around 7.5 elements, 8 elements are filled approximately. Again it will increase by 11 more. So Kumar I am adding now. So it will calculate what? Hash code for that. So once hash code is calculated, what will be the hash code? Approximately 5219. Yes. What is the key? Kumar is the key. What is the value? 11.11, like this it will store. Same concept. Okay, now I'll add what? Next is Ravi. So again for that 6521. So Ravi is the key. What is the value? 22.22. Then next Amog. So for that it will be 8915. Any number, man, just the hash code. 33.33. Next is Vinay. 9213. Balaji, somewhere it might come here. So the hash code decides the slot in the bucket, remember that. And luckily again for us what? Here also the rule is there, whatever keys you are using, the key should be overriding what? Hash code and equals. That is mandatory. Luckily for us, string is overriding it. So this is what happened. Yes, next I'm adding what? Integer. So dissimilar key. Yes, the hash code of 10 is 10 only. Key is what? 10. Value is what? 99.99. So this is how it is getting stored now. Yes, can I put a different value? Yes, possible. So anywhere it will go and store now. 8913. Ravi. This different type of value is possible. A duplicate value. Yes, I'll add 7621. Sunil 44.44. Done. So then next. So this will work. This is output what you are seeing. Understood? But null key is not possible. It cannot add it into this. That's all the problem. Null key is also not possible. Null value is also not possible. Same, understood. Done? Clear the table now? So you cannot add what? Null key and null values into this. So this is the behavior of Hashtable class. Class Hashtable. Don't think about now. Hashtable class is using Hashtable data structure to store its keys. So null key and null values are not allowed. Fine. So now we'll see the other methods of Hashtable. Okay. All the methods what you saw in HashMap will be same for Hashtable also now. So the methods now contains key, contains value, get. Okay, all those methods will be same now. Size is empty. All those methods we can see now. This is the Hashtable object. So be clear with this example, because always the first example in all the collections are the foundation for the next examples. Okay, that's it about this example. Then we'll go with the second example. Yes, you can see now what is the method I am calling? Is empty, size is empty. Initially is what? True. Size will be what? 0. Okay. Then I am adding key value pair. Fine. Then I am checking his size, which one is empty, is false this time. Size will be 5. Okay, and using same key, what will it do? Updates the value. Okay, then getting a value. How do you get a value? By using the key. By using the key. So I'll say get of Ravi. Automatically I'll get the value of Ravi. The next get of Tom. Key is only not there. So from where you'll get the value? So this time it will be null. Then remove. You can delete it. Yes. See, contains key is 1.2 method. Contains is 1.0 method. So it will support, it is re-engineered. Same functionality. Functionality is same, but the difference is 1.2 and 1.0 method. So contains method was there in dictionary class. Okay, and now it is dictionary class had very few methods. Let's see the dictionary now. Okay, anyway, I'll show you the output, then we'll see. Key Ravi is present, key Rama is present, then contains value. Understood? So you can same methods, nothing, and I can clear hashtable.clear, all the elements will be deleted now. Same program. So is empty is true, size is what? 0. Is empty after adding values? False. Size is what? 5. Now after adding I am printing all the values, correct? Now I am saying get. I am getting the value of Ravi by saying hashtable.get method. I am getting it. But for Tom I am not getting. It is null. Then I am deleted winner here. Yes or no? Go through the program like this. Then key Ravi is present, true. Key Rama is present, false. Then is present, double quotes I used. Sorry, contains value in double quotes, false. Contains value in object style, okay, in which one? New double style, correct. And after clearing these are the values. You can go through here one by one, you can see all the output. See, first is empty after adding, before adding values, true, 0. Then is empty after adding values, false, this one. Then I used Ravi here, updated, so that's why Ravi will be what? Not 11.11, 99.99. Now I'm getting the value of Ravi, yes, value of Ravi is 99, value of Tom is null. So I'm getting a value using the key, I can delete. Okay, so after deleting, then I am checking, contains value, false, because I'm checking in string style, but if I check it in double, true. Now I'll clear, and then next value in a table after clearing is no values. Same program. Done? Okay. So that's about hash table now. Yeah. Then we'll go with the last program, which is about iteration. Understood? You know, iterating through keys, iterating through values. Same. Okay. You know the diagram, no? Same diagram it is. Actually, it is told like this, but when I say yes, first we'll see how to iterate with C. Now iteration you have to see it in two styles. One is with iterator, second one is with enumeration. So let's see this now. Yes, you know this key set. Return type is what? It gives you a collection of only keys. It is giving you a collection of only keys. Yes, start iterator. So getting iterator to that, and I'll iterate now. I'll get only what? Keys. Yes, first see this output. See, only keys you are getting. Now using these keys, what you can do? You can get the values also. That is normal. Done? Okay, next. Iterate using only values. And I have commented there beside, see there. This is 1.2 method. Understood? So hash table dot values. I am iterating only through what? Values. Done? Then I can iterate only with, say what? Key and value. Both. Key and value. That is what? Map dot entry. Map dot entry, you know, no? So map dot entry is what? Inner class. Get key, get value. Typecast it accordingly. Because the keys of type integer I have typecasted to integer, the values of type string I have converted it to string. Yes, now we'll go with the legacy style. So this is re-engineered. You understand what is re-engineering? It will support old plus new methods. Yes, hash table dot keys. Directly you'll get what? Enumeration. Enumeration of what? Only keys. See this? And using the key you can get what? Value. Same. So first I show you only keys. Done. But I am using what? Enumeration. And I commented here, notice 1.0 method. Here also I have written 1.2 method. Notice that. Clear? So fine. Using the key I can get what? Value. That is also true. Yes, I comment this, then you can see the proper output. Now I will see only key values. Done? Then next, yeah, so in the old style 1.0 you are able to get only key or able to get only value. Understood? Means here see this method keys, today we are using key set, and for values you are using values if you want the values, but here you are using in legacy elements. So you are either able to get only keys or values, but you are not able to get key and value. So that map.entry was introduced in 1.2. Okay, so let's see this, I show output, then I'll talk about all that. So I am getting only values now. To get only values, what method I am calling now? Elements, hashtable.elements. So you are getting only values. Okay, so if you want you can go here, check. Hash table. Yes. See, class hash table is extending dictionary, implementing what? Map, both re-engineered. Let's see what is there in dictionary. Hardly there are few methods, man, which you already saw. Elements, enumeration, get, for getting the given a key. Earlier also the same method was there, get and put. So dictionary is having the same method, remove, it's the same method, common method, size. Okay, so these are the few methods which are present in dictionary, and it was released in 1.0. Done? Okay. Hash table. Now coming to hash table, and if you want literal information about when map.entry was released, see all versions you can find. It was released in 1.2. Done? So rest all are common methods, what you can see here in hash map. Almost all same. Done? Okay, then so that completes hash table. Done? So then we'll go to the next class called as properties. See, properties also is one more legacy. Understood? And it was supporting key value pair only. Same problems, but it has same thing as what? Hash table, because it's extending, but some features are extra, that's it. So you have to only study what are the extra features, nothing more. Understood? It's also synchronized. It will also not allow null key, null value. Some features are there which are extra. Are you clear this? So I'll just show you now which are or 1 second, we'll complete off the difference between what? Hash table and hash map, and then I'll come to properties. Yeah, we'll see the, I think that will come midway, but just manage anyway. I will give you the document, no? The table, if it comes midway, just balance, handle it. Hash map and hash table. I put it in a single screen. Is a new class, hash table, sorry, hash map, that is legacy. Hash map is not synchronized, that is Many threads can access the same object concurrently. But hash table is synchronized, that is only one thread can access the object at the same time. See here only a few things are there. I have written, I think it should be visible. Hash table is synchronized, only one thread. Okay, if this diagram is calling an abstraction, just this one can access the object at the same time. Hash table is synchronized, that is only one thread can access the object at the same time. Is it visible now? Okay. Then again, null key and null values are allowed. There null key and null values are not allowed. Hash map can use only iterator, but that can use iterator and enumeration. Similarities, both are used to store what? Key value pair, both store keys in unordered way. Both do not allow duplicate keys, both allow dissimilar keys, both allow duplicate values. The elements which are used as key must have overridden hash code and equals method. Both are eligible for cloning and serialization. So this is all about hash map and hash table. Understood? Done. So now we'll move to the next class, which is properties. And properties, you know the hierarchy now, is a subclass of what? Hash table. So straight away we'll move into examples only. Straight away we'll move into the examples. Almost all same concept what you learned, same program, only I'm changing what? Class name, nothing else, same methods. Same thing. So when I am doing this, same way table is created, but this time what is the object? Means which object I have created? Not hash table. Properties. Same it is. Here OP is the object I have created. So same thing. Okay. So no difference. And see, this is how the key value will be stored. And null key is not allowed here also. Null value is not allowed here also. Same story. First I'll show you this output. Done. Order is not guaranteed. Done. So like this it will store. If you want, you can try storing what? Null key, null value. You'll get what? Null pointer exception. Done. So fine. Same you can try with value also. This will also give you null pointer exception. Means it will not allow you. So same functionality. Done. So getting it done. So the hash table is constructed for this also. Yes, next. Is size empty, same methods, no change. Only one what I have done is contains key is 1.2 method, contains is 1.0. Rest all is same. Clear, gear, size, go through everything, it is same. Done. Iteration, same. I can use what? Iterator or enumeration. You can get a collection of only keys, or you can get a collection of only values. You can go through now. Same it is. No change. Only the class name is changing. What? Properties. What code you have written for? We will type for hash table. Replace it for find and replace. It will work perfectly. It will work. Done now. Okay. Should I have to execute and show? You can do it. Okay. Fine now. See, initially when collections classes started, it was like a mountain. But now you can see working with data structure. What you are telling? Don't want, sir. I'll only do. So that is the luxury in Java you get. Understood? So that simple it is. Okay. Anyway, that's about iteration. Clear? So almost all same things. What you saw in hash table, no difference. Okay. Now we'll see some extra things about properties. So document you can refer first, then you can be comfortable. And you can see the document clearly says direct known subclasses. One of the subclass of hash table is properties. Click that. Anyway, you can browse it. Okay. So then in properties, plenty of methods are there. Some are deprecated. Don't use them. Get property. So these are the extra methods which class properties has. It is not there in dictionary also. It is not there in hash table also. These are the extra methods what the properties class is having. So it supports legacy methods also 1.0 plus new methods, both. So there is some extra methods which are not seen till now in any class. Which are linked hash map, linked hash map, tree map, hash table. So these are the extra methods which are present only in class properties. Why they are given that? We'll see it. So anyway, see get property, list, load, so many extra methods are there. Okay, a few extra methods are there, we'll see it. So now what is extra thing what properties class has that other map classes do not have? Okay, this is a very brilliant class. Even though it's legacy, this class is used in various technologies. Right now what I'm going to tell you now, you'll not understand. Okay, because you have not seen any technologies. If you have seen, you'll understand. Understood? Just get the idea of this. Okay, slowly when you start learning the advanced things, automatically you'll start understanding all this. Done? This is the only class which gives you direct interaction with the file. You'll be having files. Okay, in projects now, you'll be having file. And we name those files as properties file. Means the extension will be, you can give any extension. But in industries we follow a convention. What we do is we give our file with the name anything hello dot prop or hello dot properties, like this we give some, we'll have some files. And in anything, any extension, in fact you can have hello.txt also. But the thing is people will get confused, what is txt having and all that. So what happens in projects now, sometimes we'll have some files which will be having some configuration values. Okay, configuration values. And what we do, those some values of the project, required values of the project will be kept stored in some files. And from these files, we'll read it into our application. So this is only a convention what we follow. Don't think because class name is properties, file name also should be what? Nothing like that. Understood? So this is only a convention what we follow. Whenever you are storing any configuration values in some file, external files, okay, we name it as .prop or .properties, anything like that. Name can be anything. The name will be generally the name of your project, like mybank.properties, something like that. Understood? So let's see. You'll understand all these concepts later. Just an introduction I gave you. So supposedly there are some values. Now see this. Like this you'll store. I just got some sample for you. But edit plus I'll open. This is, see what is the extension of this file? .properties. So how you store values in that is by using what? Simply like this you'll use. Some name means something you'll have on the left side, something you'll have on the right side. So what is there on the left side becomes key. What is there on the right side becomes value. So you'll be having files like this. Means some information stored in some files. Okay. So what happens now? These values which are there in this file, I can read it into my application. Okay. So we'll see it how to do. So what I'll do is see. And now you can keep that file anywhere, but for convention purpose I'll keep it in the same project. Okay, so where will I keep it now? See, I'll click on right click. I'll click on right click on what? Project. New. You can keep it anywhere, only you have to give the path now to load that file. You can keep it anywhere, but I don't give big path. So just I'll keep it in the project so that without any path I can read it. Okay, see this, what I'm doing? Right click on the project. Right click on the project, new, I'll say file. You can give any name. I'll give the name as cluster or any name you can give, dot properties. Save it. So I mean see, now what I'll do is, whatever values are there from here, assume that this was not there only. This I bought it for reference. Understood? Assume that I'm creating a totally new file here called as what? Cluster.properties, and I'll type like this, something like what? Karnataka is equal to what? The capital. Okay, Bangalore. Anything like this you can keep, but left side becomes key, right side becomes value. But I'll just paste it off. Understood? So your file is ready now. I'll delete off this file. This is not required because I can't type. So that's the reason I bought it in one file. I've stored it in one file. So see this. Done. So what did I do? Assume that I've created everything newly here. Don't think it should be there in D drive somewhere else. Directly you can create a new file here, store it. Yes. So these are the values which are there in the file. I want it in my, it is secondary memory now. Where it is? It is in hard disk. This file is in hard disk. Okay. So the values from this file, I want it into my program. Terrific ask now. What are you asking for? That too in what? Clearly, left side should be key, right side should be value. Like that you're asking now. Big thing. Okay, in other languages you will die coding all this. But see in Java what we do. File input stream is equal to new file input stream of what? The name of the file you give, whatever the name of your file. Cluster.properties. Now I'll create what? Property is equal to new properties, and I'm calling which method? Load method. Yes, now you go and refer to the document. Now you'll understand. Earlier when you referred, you didn't understand. See this. Load I'm calling now. So what are the arguments it will take? Either of type input stream or of type reader. Means either you can use file reader or you can use file input stream, subclasses. Same thing I'm doing. What did I use? File input stream. And what did I say? Load. Finished. All the values from the file have been loaded into what? Where they have been loaded? Into your Java program. I'll draw it and show it for you. Done. It is there. Now see what I'll do. After loading, now simply I'll say property dot list. These are the extra methods of properties you are learning now. 2 lines of code when already you got the values from the file into your program now. Use how you want now. So like this what we do in projects now, we'll keep it outside and we'll bring it into our application and we'll use it however you want. So here I'm showing it a simple program now. So just see this. So property.list system.out. See the method I'm not using system.out.println. Property.list method requires an argument of type what? List. Print writer. System.out also I can pass or I can send print stream also. Out is an object of type what? Print stream. That's it. System.out. See here, printing. From the file it read and stored it into Hashtable. So if you want the clearer diagram, see what is happening. Anyway, it's printing now. Not only that, you can use all, see it's print, list will print all the values to the console. List will print all the values to the console. But if you want to use it, see I can get value one by one also. If you know the name of the property, you start get property of what? The key, Karnataka. So what will happen now? I'll get it. Same. So if you want clear idea, let's see the diagram now. So this is an extra feature what properties class has over other map classes. You can directly interact with the file system and retrieve the key value pairs. See now there is one cluster.properties file. You can give any name. I'm telling you, it's not that I have to give cluster only, the extension should be dot properties only. It is only a convention what we follow. Understood? So the name of the file is cluster.properties, or you can even name it as abc.prop. This is also valid. Prop also is sometimes we do, but don't name like this. What? Something like apple dot, name can be anything, that is secondary, dot txt, dot doc. Now it will be confusing. Dot doc means you'll think it's a Word document. So only in convention what. So these two don't do it. Okay. So in this file what have I kept? Key is what now? Whatever is there is on the left hand side is the key now. Karnataka becomes what? Key. Okay, and this will be the value. So what is the first key? Karnataka is equal to value is what? Bangalore. See, I am not typing their key and value. See this file. The next one is Maharashtra, Mumbai. The next Andhra, Hyderabad. Then Tamil Nadu, Chennai. Then it's not that you have to store always strings only, you can keep numerics also. Anything, just some concept. 11.11 is the key, value is 22 point, anything you can keep. Anything can be the key, anything can be the value. But it is read, whether it is any style, it will be coming in the form of string only. Key will also be string, value also will be string. When you read the values from the file now, always you'll get it in the form of string only. You have to do the conversions now if you want to use it. Okay, means string will, 11.11 also are getting a string that you have to convert to double and use. If I keep 100 is the key, 50 is the value, I have to convert it into integer end user. That's all. So that's why data conversion is very important. Clear? You know the conversions. So fine. So this is the case. Now what I'll do is these values. Just let me remove all these complicated things. Let's keep it very simple here. See, this is my Java program now. See, don't think I'm writing key value in the file. Just for understanding, I've written it. Left side will be the key, right side will be the value. Understood now? Just for understanding. Okay, fine. So this is my program now. So what is the code we are writing in the program? File input stream FIS is equal to new file input stream of, you have to give the path. But since it is there in the same folder, you don't have to worry. You can give the relative path. Sorry, absolute relative path. Okay, otherwise if it is there in different drive and all, you have to give the absolute path. Okay. So here I'll give it as cluster.properties. So as soon as you do this, what happens? Your program gets connected with the file. Yes or no? Your program gets connected to the file. So simple. Now see, this is the file input stream object now. And it is of type what? Byte string. That's it. So on stream, what is stream? Stream is an abstract layer which carries the data. Java input output, I have covered all this. So on stream gets created between your program and the file. Okay, so that is done. So what will I do? This one, properties prop is equal to new properties of FIS. Where I am passing that stream to the properties object. All I will do is prop dot load. That's it. I am calling a method. So all the values from your file will be loaded into what? Primary memory now. All the values from the file will be loaded into the primary memory now. And how? See, Karnataka. So one hash table will be created now. Yes or no? What will be the capacity? 11. So this is hash code. And this will be key. So this is your property object. Understood? This is your property object which is getting created. So what is the hash code of Karnataka? It can be anything. Don't worry too much about all that. But see, if the hash code of Karnataka is 1298, Karnataka becomes the key. What is the value? Bangalore becomes the value. So like this it gets getting stored. Maharashtra. For that 5162, Maharashtra is the key. Mumbai becomes the value. So like this, all the values which are there in your file is getting stored into the hash table now. Primary memory. Unimaginable it is. So what luxury you get in Java? See this. Then next, Andhra. 2165. Andhra. Hyderabad. Then Tamil Nadu. Chennai. Then 11.11. Sorry. Yeah, I think for this also it will be the same hash code. Okay. 11.11. This is the key. Value will be what? 22.22. Like this it is stored. So now from this is the properties object, and you know how to work with the properties object now. Till now we are hard coding put. Till now what was I doing? Properties dot put we are saying, but now I'm not saying put. I just said load. That's all the difference. A store is same, and iteration, getting the values from using the key, checking is contains key, is empty, size. A store is same. You know how to work with properties? That's it. Only difference is we didn't hard code the values. We got it from the file. Done now? So now that's what is the next I wrote. What is that I wrote? Property dot list system dot out. What did it do? The contents of this it wrote to the console. All the values it printed. What it printed? Karnataka. This is your console. Console means what? Monitor. Okay. Karnataka it printed and Bangalore it printed. Means in whatever way it's stored. It is stored in the Hashtable now. Then 11.11. This is output what you are seeing. If you say this property dot list method if you say. One more I used. Property dot get. I think property is the method you called. Something. Let's see what is the method. I said Karnataka. So that value I am getting into the program now. The return type of that is string. I can use this. Understood? I can use this. So like this, see, this is the one. Property dot get property of Karnataka. I can use it. It is in this program. But this was printing to the monitor. What you want to do with that, you decide, man. Okay, if you want to use it in the application, use it. You want to print, you print. You want only some value from the value, then use the key, you get the value. So this is how it works now. Are you clear the diagram now? So I'll clear this now. What I have written? Yeah, one by one we'll see the methods now. Just manage because I need this diagram. Just little bit you manage. So are you clear with these two methods now? Property dot list and yeah, this method is clear now. Yeah, done. So it's printing all the values here into the monitor. Okay, key value listing properties. That's the extra message what it is printing. I didn't print that listing properties. Okay, so then next we'll comment this. Yeah, you know that value is it will print Bangalore. Fine. Next, you want to iterate? Iterate. Property dot key set. Normal. Nothing different here. Key set iterator. I can use only the means I can iterate only through keys. So iterating only through keys. 11.1 is the key. Maharashtra is the key. The next, if you want, okay, see that was 1.2 style. If you want, you can go with what? 1.0 style also. Key set is the method you can use, or you can use property names. This is also one more method of property. 1.0 method. Return type is enumeration. I'll get only keys. Only keys I'll get. Property names will give only keys. Done. Then, yes, one very interesting thing now. From that file, I want to read and write to another file. Fine, see this. Hello, I want to write it to which one? Hello.properties. So properties.store is one more method. What you are saying now? Store is one more method. I have to pass object of file output stream, and any information is for any file you have some header now. Look at the method here. Store, yeah, store string. I'm using this one now. Output stream and comments. I'll show you when you see the output, you'll understand. Comments. So you can use this. So what it is doing now, right now, very interesting. What it will do now is, it is when I run this program. See, all I am doing is to this line now. Just focus on this. After loading, I'll just say file output stream, this one, and I'll say properties dot store. You have to create the object of file output stream, and you have to give some message here, my file or something like this. That's it. So when you do that, the entire contents which is there in the hash table will be written into one more new file called as hello dot. What is the file name I'm giving you? Hello dot properties. Directly it will write in hello dot properties. How it will write? Same. In what way it is storing, that way it will be writing. So we'll see the output. So hello.properties file is not here, it will get created. Understanding now the power of this? It can read from the file also, it can write to a file also. It can read from the file also, and it can write to other file, or we can update the same file. Just I'm showing you reading from one file and writing to another file. Yes, yes. Look here, the file will get created here. Default. Where's sorry? Default will be creating the project place. Okay. So I'll do it now. Finished storing. This it's printing. SOP. But keep here and say refresh. Can you see? It came out. Hello dot properties. When I refreshed it, it came. Otherwise, it will not come. You know how to refresh now? Right click. This one you press, huh? Okay. Refresh you do. Okay. This one you do, or you press F5 shortcuts, Eclipse. So fine then. So hello.properties is there. Now you can see. So based on how it was stored in Hashtable, it is storing. Not like the same file. How the values were stored in the Hashtable, that it has been returned to the file. Okay. So what is file output stream now? It is one more object you have created, file output stream. And it is using again which type? Byte stream. And is writing 11 according to the values how it is stored in the hash table, not according to this file. Understood? And now see the header, my new file. I just give the what is the header I want. Anything you can give, and along with that, date, time, and all it is printing. Understood? So properties class is one of the very powerful class, and it is used extensively. Okay, because this is the only class which has the ability to read from a file now and interact with file system. Okay, so we'll store and we'll use. So when we write applications, you'll understand the grip of this. Just have the idea. Okay, it supports. Understood? You should know what is what in the library, where it is there, how you want to do. That much if you know. So these are all concepts we are learning. Am I any day teaching you output? Huh? I'm not teaching you any output here. Remember that. Always I'm teaching you concepts. So this is on concept. See this support. This is on concept. This is on support. Clear this now? So always see till now you are thinking you wanted to write logics. Nothing, no logic. All logics, what is there? They are common. Understood? And they have already been written and put in the library in Java. That is what you first understand. Okay. So usually when you come out of college, you have the Josh. I want to write that kind of logic, this kind of logic. Today no logic to write. Every logic is already ready here. You just have to know where it is and use it. So imagine till now you have learned so much of Java things. Okay. Hardly 40 days language is finishing. This is one of the easiest language you can finish so fast. And later on what you have studied is the library. Understood? So in other languages, you continuously study the language. Continuously. Language, and then what you do? You write the code, which is too much for any developer. So that simple Java is. Okay. It's all about people learn it in a wrong methodology. They learn it in a wrong methodology and they say Java is big and vast. Java is not big and vast. Java is a very simple language which can be learned and understood in 20-30 days. Whatever things we learn in Java is only about library. Understood? Whatever things we learn extra will be from the library. So that will take time now because there is no end for library. Okay, you go to any library, there is no end. Understood? Physical also I am talking. You go to your school library. Can you finish it learning? Never ending subject. So same way here also. But what you have to learn here is for our applications, how much support is required. Only those we go on learning. Because I want to develop web application now. That is my target. Or mobile application. Okay, means Android applications or something like that. For that what is required? That we go on learning. Okay, it's specialization. Understood? So done. So yes. Yeah, you are clear with this now? Reading from file and writing to another file. Rest all. See, if you know how to work with the properties object, everything is same now. Only I showed you extra is what? Instead of saying put, I said load. And one more I will use this store, which will be putting into that file now. Shall I clear this diagram now? And if you at all you want to write this file to any other location, you can give the path. I just said hello.properties, you can give your own path also. Done? Okay. Okay, some notes on properties now. Properties can store what? Key value pairs. It uses hashtable data structure to store the keys. Same story. It's a legacy class and it was extending dictionary class. Properties is re-engineered to fit into collection framework and is implementing map interface and hence supports both 1.0 and 1.2 methods. It is synchronized. You know the meaning. It has low performance and okay. Before to Java 1.2. Only enumeration you can use, but after 1.2 you can use iterator also to iterate. Then is the only collection class which can interact with what? This is the important point, 8th point. Is the only collection class which can interact with the file concept directly. It can load the key value pair from file and store also. Both it can do. Yes, this class is extensively useful. Yes, get this point because when you are learning struts, JSF, there you will be clearly understanding. Okay, this class is extensively useful and is used in technologies like struts, JSF, etc. to read key value pairs from dot properties file. Dot is there. Dot properties file. Okay, the key value pair from a file will be always of type string. That you should understand. Whenever you read from the file, key and value will be always of type string. Done. And the keys will be unordered or undefined. Duplicate values are allowed. Different type of keys and values are allowed. Rest all is same. So some extra methods are there in class properties. That's it. Understood how to study the library now? Yes. So having covered this, next we'll move to one more class called as collections. One more class called as collections. That's all about properties. Okay. So we'll move to one more class called as collections. You know, collection is an interface. We are left with one. We had used this method collections.sort. Yes. Yeah, we are coming back to this collections now. Very simple class, a very general class. Okay, and this can be used with any collection class. Okay, so remember we say these 4 classes: enumeration, iterator, list iterator, and collections. These 4 classes: iterator, list iterator, enumeration, and collections. Look. These are all classes. Yes, I am writing. They are not collection classes. They are support collections. They are supporting classes, we say. See, linked list is collection. Hasset is collection. Preset is collection. Is iterator collection? No, but it supports collection. Understood? They are supporting classes, we say. Similarly, collections is also what? A supporting class, which supports collections. Understood? What support? Yes. Now see. The collection framework supports several algorithms that allow us to operate on collections. We can use these algorithms to sort, shuffle, manipulate and search a set of elements in a collection. You want to sort, you want to search, you can use this. You'll see it with the example. Some of the algorithms available in the collections framework are sorting, shuffling, manipulating, searching. Okay, these all algorithms are present in only one class now. Instead of giving one method in every class, what did they do? See, for sorting, they didn't put the method in array list and linked list. Instead, they put it in a general place. Means in vector, stack, they didn't go on providing what? A sort gate and all that. That common things they kept it in one class called as collection. We'll see it. So then these algorithms are present in collections class. The collection class also provides method for getting a synchronized or unmodifiable list. So this is a very important question. How do you get a synchronized list or unmodifiable list? Because generally what happens is, whenever anybody asks you how do you get a synchronized list, they think vector is the good way. First of all, you should not store values in vector. It's because it is synchronized. We know that it's synchronized, that's why we are avoiding it. Instead of that, I will be using array list. So first you will fill values into array list. Then suddenly you find that I want to synchronize the array list. Yes, you can do it. One method is there, that's all. I'll show you. So you can synchronize it also, or you can do unmodifiable. Unmodifiable means you got a list now. You can do any operation. Update, delete, add, anything you can do. I don't want that to happen. I want that to be fixed. One method you call on that, finished, it becomes unmodifiable. It will not change only. We'll see with example. These are concepts, as I told you. Again, you need what? Examples. So it's simple. See this? 2 methods, man. New methods I teach. Collections dot unmodifiable list, employee list, finish. Now try to modify anything here, list dot add, remove, not possible. Understood? Same way here, collections dot synchronized list of employee list, directly you'll get what? Synchronized list. Okay, so we'll see the output of this. But see, I have put in the last point. It is more recommended to get a synchronized list, set or map in this way, if required, if needed, rather than depending on legacy classes. Understood? So I put the point there. Yes. So that last example we are seeing is the 14th project, collections. So go there, two very simple examples. Very simple. See, collections class supports various algorithms like sorting, shuffling and all that. Okay. See this, array list is there. Before sort, you know, this method, what it will do? By default it looks for the compare to method in the elements. Anyway, it will do sorting. That's okay. Reverse, it will reverse the elements. Whatever, however you have stored it now, it will reverse it. Shuffle, finished, elements are shuffled, you don't know the order now. So simple, man. And here you can pass any list. Either I can pass array list or linked list or stack vector, anything which is implementing list. I want to find the minimum value. I want to find the maximum value. Fine. 1 second everything is solved. That is the beauty of Java's library, man. See, such huge collection. Don't think 5 values now, 10 values. 10,000 records. Now imagine how brilliant it is. Yes or no? So first initially it was there before sorting. Then I said sort, this is how it's sorted. Reverse means however it is, it will reverse it. Then this is shuffling. What algorithm they are using for shuffling we don't know, but it is shuffled. Minimum value is A, maximum value is H. Finished. What more do you need, man? So that's how it supports. And more information, yes, go to collections class. This is the one, it's a class collections. Yes. Then these are the methods. Plenty of methods are there. All methods you will not understand. Slowly you start understanding one by one. Okay. Some methods I am showing you, which are used. Max. Okay. Then something min, something like that. Okay. So many are there. Gradually you will understand. Okay. So just focus on the methods which I am teaching you, because they are the ones which are extensively used. Understood? Other methods with practice, as you go on learning, referring, you will start understanding. Get the grip. Okay, this concept is there in this class, in this package. I want some support. That support is there in some class. That class is there in this package. Immediately you should know how to go through now. So just I'm giving exposure to the library. Done? So then next, this is the one, sort. Okay, swapping you can do. Check out. Some methods which you understand you can try. Some methods which you don't understand, forget it. You will get it with experience. Understood? Gradually as you go on coding, when the requirement comes now, you will start searching automatically. And you will start understanding all these things. Clear? Okay, that's one thing now. So, this is done. Then next, yes, this is very important interview question. How do you get unmodifiable list? See here, there's one list now with 3 values. You can add more. Just I'm adding 3. Now, I want list 2. Collections.unmodifiable list is a method I've called. I'm sending the argument of this list. This is modifiable. But if I try to modify list 2, you get what? Exception. And this exception they'll ask you. In collections, why do you get? What is the name? We'll see. What is the name of the exception? Say, what is that I'm doing now? Just I'm trying to add and remove. Add Z. Should add now. And I'm trying to remove. It will not allow. First we'll see one, adding. Then we'll see removing. And I'm trying to print list 2. Unsupported operation exception. Understood? So this is how it will happen. So then next, even if you try to remove also, same thing you will get. Understood? So this is a very important interview question for you. Do not forget that. How do you get a unmodifiable list or unmodifiable list? First one. Next, how do you get a synchronized list? Finished. But this, there are no multiple threads for me to show, but just get the concept now. Right. So the problem with Eclipse. Yeah, here I cannot show because there are no multiple threads. Okay, so just understand we can get a synchronized list also. This is a better way rather than depending on legacy classes. Done now? Yes, I have just showed you the most important methods. Done? Okay, then yeah, I think I have given you the notes for class collections also. Okay. See, almost all I covered everything now. One topic I had not covered, a small topic that I finished off 5 minutes. When I was teaching you set, tree set, I didn't talk about the methods present in sorted set. Okay, I didn't talk about the methods. Similarly, when I was teaching you tree map, I didn't talk about the methods present in sorted map. Just I'll finish it off. Very simple it is. So just look at the API. Frames. Sorry, we are already there in frames now. Okay. I think. That's it. If you know this much sorted set, first I'll go with sorted set. Some methods are there. First, last, simple man. First element, last element, tail set, subset, head set. 5 methods I'll teach you over. Understood? So what are those 5 methods? In fact, I've added those programs in tree set only. Understood? And the program number is tree set demo 3. Okay. See, I'm adding the elements in this order. 20, 10, 50, something like this. This is the order you added. But first will be what? 10. Yes or no? Last will be what? The highest one, 90. This, you added in this way, but first will be, see, this is the original one. This is how you are adding originally now. How? 20, 10, then say 50. 20, 50, then 10, then 60, 30, 40, 70, 90 and 80. But in tree set, this is how it's stored. How it will start? 10, 20 means in ascending order, but default 10, 20, 30, 40, 50, 60, 70, 80, 90. So obviously first will become what? 10, last will become 90. That's it. These are also asked in SCJP, so that's why I just covered it. Okay, and just yes, done. And next, okay, so head set, what will it do? Can you guess? It will give you a set. Return type is sorted set. Okay. But from means head portion up to 50, but 50 will not be included. Understood? So head set method will give you up till here. 10, 20, 30, 40. I think 50 will not be, yeah, excludes 50. It will not take 50. That's how they have written the code. That's it. Head set. So this is what is your sorted, sorry, what is that? Head set. Okay. Just change the variable now. Okay, 50 will be excluded. That's it. Done. Tail set, same. What it will do? Leave the tail portion. That's it. But this time it includes the number what you are sending. For tail it will include from 30 till the end. Understood? Tail set. So what does the tail set method do? But it's actually stored in tree structure. Just by understanding I am drawing like this. So what is the tail set doing? From 30, 40, 50, 60, 70, 80, 90. This is tail set. So this method is head set method. This is tail set method. Understood? Then next, subset of now between the range now. That's it. So from starting range 30 it will take, but it will not include 70. Just understand how it works. That's it. You don't have to worry too much. Starting from 30 till 70, but 70 is not included. Understood? That is subset. One more object gets created. You know how to draw it. That's it. Okay. Subset will be like this. See, this is original. This is stored. So what will subset method give you now? This is ESS. What is that? 30, 40, 50, 60. That's it. Done. So these methods are not covered. So just I covered it off. Okay, so almost all the same is what with tree map now. Tree map also will become what? Sorted map. So that example where I put? In tree map I put. I'm teaching you now sorted map. Okay, in sorted map, see I put it in the fourth example. Program to show methods of sorted map. Same key value, first key, last key. So it will give the first key, last key. Then head map. So this will be a map, means it will contain both key and value. Then this one tail map, this one sub map. That's it. Done? So getting the idea? So any map you can get. So means first key, last key, only key you will get. There you are saying first, last. Here you are saying first key, last key. Other things are head map, tail map, sub map. And here you will get key and value. Understand? So that's all about that's the support. Okay, we were getting in Java up to 1.4. Okay, some more enhancement. See, like 1.0, some features were given. 1.2, something was added. 1.3, 1.4, they added. I'm not saying no, but let's not highlight on that. Okay, but where we find major difference, we highlight. 1.0, okay. 1.2, major difference. We'll study. 1.5 also major difference. So we have to study. Okay, so we'll be studying the features of 1.5 from the next session now. Okay, and here, see what came in which version, that you don't worry now. You don't have to summarize which method came when, which class came when, all that you don't worry. If you want that support is there in this class, this method. Use it, start using it, that's it. Okay, when it came, why it came, where it came. While studying, we study like this, sir. But when you want to use, be simple, calm, start using it. And no interviewer also will ask you when it came, where it came, why it came. That's only for your good grip of understanding. I have taught you like this. Understood? So that the idea is only for you people not to by heart the subject. Okay, I just wanted to put these things in an analytical way, because by hearted things always forget. Okay, analytical things you will always remember for a longer time now. So I picturize this and put this in your mind now so that you will never forget collections. I just one type of picture I put into your mind now, like this is how it will be, this is how it will be, this is how it will be. So that completes what 1.4 support of collections. Understood? So we'll see again more features have been added. Excellent features are there. Okay, still better. Concept is same, but there are some drawbacks here which we'll discuss, and that is the reason they've added those features. Simply Java is not giving all the problems, so means increasing the library for our problem. They are giving it for what? Our benefit only. Unfortunately, people do not realize that and understand that. They'll say simply Java is big, Java is big. Here Java is not big, language is very small. Libraries are big. That is the problem what people are not able to understand. And unfortunately today also you go and ask somebody, okay, in Java there are libraries, they'll say what do you mean by library? This is how people have understood Java language. Understood? So due to that they find the language difficult. They go on learning what? A.M1, A.M2 only. Other than that they don't learn anything. A is equal to new A.M1 is what Java they think. Unfortunately that is a problem. Anyway, we have completed up till 1.4 collections now. In the next session when you start off, we start off with 1.5 and the new features. So history wise I have taught you, you will be very comfortable, and throughout your life you can work very easily with collections. Done? Okay, that's it done.